Module 3, Investigation 4B, Function Composition. Number 1. Timothy works 30 hours a week between two part-time jobs, a waiter for $9.25 per hour, and a math tutor $8.50 per hour. Since he only has 30 hours each week that he can work, the more hours he spends at one job, the fewer hours remain for the second job. Okay, first of all, that $8.50 per hour is a pretty low rate for a math tutor. When I started tutoring math, I charged $12 an hour, but if you ever want to start tutoring, you probably shouldn't go lower than $20. Okay, anyways, back to the problem. Sorry about that aside. Assume that Timothy worked a total of 30 hours this week, and he worked 9 hours as a waiter. How much money in total did Timothy make this week? Explain how you determined your answer. So think about this before I tell you the answer if you haven't already. But first of all, since he's worked 9 hours as a waiter and he makes $9.25 per hour, we simply have to multiply those amounts to figure out how much money he made as a waiter. So $9.25 times 9 is $83.25. We've talked about this before. If we take a rate, the number of dollars per hour, and multiply by how many hours, if you want to think about this as the hours canceling, so you're left with dollars for your units, you can do that. Okay, next, that's just how much he made as a waiter, but we need how much he made altogether. So if he worked 9 hours as a waiter, but he's also working as a tutor, how many hours does he have to work as a tutor if he has 30 hours altogether to work? Well, we can just take that 30 hours and subtract 9 hours, and that gives us 21 hours. Remember that he only has 30 hours to work each week, so he's got 21 more hours that he can work as a tutor. So we simply multiply the rate that he can work as a tutor, the $8.50, and multiply that by 21. So multiplying $8.50 times 21 gives us $178.50. So now we have the amount that money he made tutoring and then the amount of money he made as a waiter, and we can add those up together to get how much money in total Timothy made this week. So that's $261.75 that Timothy made working 9 hours as a waiter and 21 hours as a tutor. Part B says our goal is to define a function that determines the total amount of money Timothy makes when he works X hours as a waiter. Notice we can basically look at our process we've done up here to figure out how we're going to do that. Here he worked 9 hours as a waiter, so we can multiply that number 9 times the rate, $9.25, to get how much he made as a waiter. Then we needed to find the number of hours worked as a tutor, just 30 minus 9, and then multiply the rate, $8.50, times that number. And then add those two numbers together. So this is, Part B takes us through step by step in that process. First, they ask us to define a function h that determines the amount of money Timothy makes for working y hours as a math tutor. Well, we simply have to take the number of hours worked and multiply it by his rate. Our function h, which is the amount of money that he makes, will simply be the rate at which he makes money tutoring, which is $8.50 per hour, multiplied by how many hours he's worked. And so then that's our variable y. So h of y equals $8.50 times y. Take a second to think about that. Part 2 says define a function k to determine the value of y, the number of hours Timothy works as a math tutor, in terms of the number of hours x Timothy works as a waiter. This problem isn't so bad if you just take a moment to think about it. We just want a function k, so just jot that here, k, to determine the value of y, the number of hours Timothy works as a math tutor, in terms of the number of hours Timothy works as a waiter. Notice it says that we want k to determine the value of y, so really what our function k is going to do is determine the value of y. And notice that k is going to be a function of x. Determine a function k to determine the value of y, the number of hours Timothy works as a math tutor, in terms of the number of hours x. So x is going to be our input into our function k, which will help us find this quantity y. And just like we did above, where we had 30 minus 9, we can find the number of hours that Timothy works as a tutor by 30 minus x. Notice the connection between these two parts, with the y as the number of hours worked as a tutor and x is the number of hours worked as a waiter, and the relationship between those two. Y equals 30 minus x. Part 3. Define a function g that determines the amount of money Timothy makes for working as a math tutor when he works for x hours as a waiter. And this is kind of a fun problem. So we want a function g that determines the amount of money Timothy makes for working as a math tutor as he works for x hours a waiter. So we want g as a function of x. But what we really want is a composition of functions. We have, let's see, we want the amount of money Timothy makes working as a tutor, which we have a function for that right here, the function h. So we really just want to look at our function h, but we want it in terms of x instead of in terms of y. So what we need to do is take the input here of x and plug it into this function k and take that output and make it the new input for h. So this is a composition h of k of x. Which just means that we take k, which is 30 minus x, and substitute it in place of y in this equation here, and we have 850 times 30 minus x. Now, there's a lot of math there, but it really should make sense. It's not too complicated to think about this. We're just taking the rate at which he works as a tutor, 850, and multiplying it by the number of hours he gets to work as a tutor, which is determined by the number of hours he gets to work as a waiter. Part 4, define a function f that determines the amount of money Timothy makes for working x hours as a waiter. Well, we know that he makes $9.25 an hour, I believe. Yep. So this function f just has to take the number of hours that he works multiplied by the rate. 9.25 is the rate times the number of hours that he works as a waiter, x. 5. Define a function t that determines the total amount of money Timothy makes in a given week, working both jobs in terms of the number of hours x he works as a waiter. So this function t just is the total amount of money he works in both jobs. So we have in part 4, f of x is the function that determines the amount of money he makes as a waiter. And then in part 3, we have the total amount of money that he works as a math tutor. And notice they're both in terms of x, which is what we want here. We want our function in terms of x. So this function t of x will just be the addition of the functions g of x and f of x. And the order doesn't matter here. You could write f of x plus g of x. But essentially, we take, I actually would rather reverse the order, but I'm not going to. Just here's 850 times 30 minus x is g of x. Notice that this is just the total amount of money he works as a math tutor. $8.50 times the total number of hours, which is 30 minus the number of hours he worked as a waiter, plus f of x, which is 9.25x. total amount of money he works as a waiter. So there's our function T. Now part C says the restaurant Timothy works at requires its employees to work between 15 and 25 hours each week. What is the domain of function T? What is the range of T? So remember the domain, this all goes back to the definition. The domain is the set of possible inputs, and our input for this function T is x, and x is the number of hours worked as a waiter. And so if the restaurant requires that Timothy works between 15 and 25 hours, then the domain of the function is all the values 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and even all the ones in between, like 15 and a half, 19.25. It's all the numbers in between 15 and 25. And the best way to describe that is with interval notation. So here's our interval notation. Notice the domain is just the range of numbers, not the range, I'm sorry, just from 15 to 25. Those are all the possible inputs. This includes everything in the middle. And we've also included 15 and 25. We're just assuming that it's okay if he works 15 or if he works 25. If he could not work up to 25 but had to work less, you could put a parenthesis here. But we're going to put a bracket this time. Okay, now how about the range of the function? Well, since the domain is 15 to 25, that represents the smallest amount of money he can work is 15, and the maximum amount of hours that he can work is 25. So if we plug each of those values into our function T, we're going to get the smallest amount of money that he can make and the largest amount of money that he can make respectively. So notice I just took 15, the initial value of my domain, not really initial, it's really just the smallest, the minimum value of my domain. Plug it into my function T, and I got 266.25. I'm making a lot of errors in my words today. Sorry guys, I think I need to make some coffee. So that 266.25 is the smallest amount of money that he can make in a week, because he has to work at least 15 hours. So that's the lower portion, the minimum value of our range. Now we just need to determine the maximum value, and we can get that by plugging 25 into our function T. So I evaluated the function T at the value of 25, and I got T of 25 is 273.75. So that's the maximum value of our range. That just tells us that the range tells us the total amount of money that he can make in a week. He can't make any less than 266.25, can't make any more than 273.75, because he has to work between 15 and 25 hours as a waiter. And this is an increasing function. As the more hours he works, the more money that he will make. So that's that. Part D. Suppose Timothy must work at least 12 hours each week as a tutor. How does this change the domain and range you determined in part C? Notice that if he has to work at least 12 hours a week as a math tutor, then he can work at most 30 minus 12, or 18 hours as a waiter. So that's going to change this upper part of our domain here. He can't work 25 hours. The most he can work as a waiter is 18 hours. And then the range, now our minimum value here is the same, and remember that we got that just by evaluating T of 15. So the lower portion of our range is T of 15, and then the upper portion is going to be T of 18, which is 266.25, and then we can just plug 18 into our calculator. Sorry, I'm having some technical difficulties, but here's the maximum value of our range in this case, 268.50. 2a. What is the radius of a circle with a circumference of 15 feet? Okay, so we could just jump to the formula, but I'm going to be a little bit particular. Let c equal the circumference of the circle in feet. Let r equal the radius of the circle in feet. Then we know that we have this formula, c equals 2 pi r, that relates the radius to the circumference. Maybe back from middle school or something. So now, if we know that the circumference is 15, so let's just say, again starting with our formula, c equals 2 pi r, and we know that the circumference is 15, then we know 15 is equal to 2 pi times this particular radius we're interested in. And we can solve for r. Notice that r is multiplied by 2 pi, so we could divide both sides of this formula here by 2 pi. And we get 2 pi divided by 2 pi is 1, so that means r equals 15 over 2 pi. And I'm just going to plug that in the calculator. This is approximately 2.387 feet. Okay, next we need to look at what is the area of the circle with a radius of 2.387 feet. So now I'm going to define the variable a, the area of the circle measured in feet, and I hope that you recall that the area of a circle is pi times the radius squared, and we've already defined the variable r here for the radius. So there's my area equals pi r squared. Next, we just need to evaluate that formula with our radius of r. So a equals pi times 2.387 feet squared. And we get about 17.9 feet squared. Part C says, describe a two-step process to determine the area of the circle when the circumference of the circle is known. So note that that's pretty much what we just did here. When the circumference was 15 feet, we just divided 15 by 2 pi to find the radius. And then we take that value and use a equals pi r squared to find the area. Again, we must first find the radius by using the formula c equals 2 pi r, or r equals c divided by 2 pi. Then we use our area formula, a equals pi r squared, using this value here for r. Notice that we could use the composition of functions here and just plug in this value, c over 2 pi, here in place of r. Anyways, part D. Use the two-step process described in part C to determine the area of a circle when the circumference of the circle is 29.63 feet. So if I use what I've just described to you in part C, then we can first find the radius, which is our circumference over 2 pi, or 29.63 feet over 2 pi. Use the calculator. We get approximately 4.716 feet. And then we go to our area formula, a equals pi r squared. And we know that r is 4.716 feet. Notice that we square those feet so they become feet squared in our final answer, which, using the calculator, about 69.86 feet squared. Part E, define a function f to define the radius of the circle given the circumference of the circle. So we've pretty much already done this. Define a function f to determine the radius of the circle given the circumference of the circle. So we know the radius is c times 2 pi, so we want our function f to give us that value. So we simply use f of c is c over 2 pi, and notice that we could say r equals f of c. R, remember, is the quantity, it's the variable, and we use this function name f to represent the different values of r given different circumferences. Now, part F, define a function h that determines the area of a circle in terms of the circumference of a circle. So, we want the area of a circle, but we want to use our function h in terms of the circumference of the circle. And remember that the area of a circle is pi r squared, but instead of using r, like I alluded to earlier, we're just going to use c over 2 pi. So r is like the middleman here. It connects our two, it connects the circumference and the area. Pi times c over 2 pi squared. Now, this is totally correct, but we should probably get into the habit of simplifying, because we're going to start simplifying more in this course. So this is simply pi, and then c over 2 pi squared is c over 2 pi times c over 2 pi. And just think about this as over 1. Just multiply the numerators. That's pi times c is c squared over 2 times 2 is 4, and pi times pi is pi squared. But notice that we can actually cancel out one of these pi's. Pi divided by pi is 1, so we really have c squared over 4 pi. Part G, use function h defined in part F to determine the area of a circle when the circumference of the circle is 29.63 feet. So we simply use our function h. Let me just write that again once more. H of c, which is representing area, is equal to c squared over 4 pi. And we now know that our circumference is 29.63 feet, so we're going to evaluate our function. Really, I should write this. H of 29.63, that's going to represent the area of our circle when the circumference is 29.63 feet. Don't really have to put the units there, just know what they are. And this is 29.63 squared over 4 pi, and using our calculator, we get 69.86 feet squared, which was the same value that we got up here in part D. So notice that this function h is simply a composition of functions. H of c, it's really h of, I think it was f of r, or f of c. Remember that you'll also probably see this notation in the future. H of f of c. Number 3. The following graphs show two functions f and g. The function g takes as its input the side length of a square. So here we have the input is the side length of a square, and outputs the area of the square right here. A lot of times when I'm reading math problems, I don't just read all the way through, I think about what it means as I'm reading. The function f takes as its input the side length of a square and outputs the perimeter of the square. Okay, let's look at part A. Does the expression f of g of 4 have real-world meaning in this context? If so, estimate its value and explain what the value represents. Okay, so let's take a look at this f of g of 4. 4 would be the input into the function g, so that's a side length of square meters, and then the output there would be an area, 16 square meters, and then we want to make that output the new input for f, but notice the input for f is side length of square meters. We can't take an area of square meters and then try to input it into a function that takes as its input side length. So no, that's not a function. Sorry, I mean f of g of 4 does not have a real world meaning because the output of g is not the input of f. And so I got my coffee. Hopefully I'll drink that in a second. Now what about g of f of 4? Does that have a real world meaning in the context? Okay, so g of f of 4. First, 4 is the input into our function f. 4 is the side length of square meters, then f would give as its output the perimeter of square meters. And then, can we go over to g and input that here? G, the input is side of length of square meters. These again don't match. So once again, no, that has no meaning. Part C. Is it possible, using the graphs provided above, to determine the area of a square given the when, let's just assume that that's the. So is it possible, using the graphs provided above, to determine the area of a square given the perimeter of the square is 4 meters? If so, explain how, if not why. So let's just think about what we have for a second. The perimeter is 4 meters. And can we determine the area of the square? Let's go look back up at how our functions f and g are defined up here. Notice that we do have a perimeter here. That's the output of f. So if we know the perimeter is 4 square meters, then we can look and see that the side length would have to be 1. Side length, yeah, that would be 1 meter. And then, if we knew our side length was 1 meter, then we could see that our area of the square was about, this is a scale of 2, so that would be about 1 square meter. So I think the answer is yes. So again, just to recap, knowing that the perimeter of the square is 4 meters, and the perimeter is the output of f, we can go backwards and find the corresponding input, which is a side length of 1 meter. So that was right here. Got our perimeter, go backwards from the output and find the input. Then we can input a side length of 1 meter into the function g to determine the output, which is the area of 1 meter squared. So now that we know the side length of 1, we can come here and input that into our function g and find the side length of 1. And this should all make sense in terms of a square. If the perimeter is 4 meters, you can draw your square. That means there has to be 1 meter on each side length, and then your area is just 1 times 1, the length times the width, and you get 1. Part D says our goal is to determine the area of the square given the perimeter of the square. Part I, what information do you need to know in order to determine the area of the square? So notice that all we needed to determine the area of the square was the in part C, all we needed was the perimeter, and we could determine the area of the square. We also know that if we just had the side length, we could determine the area of the square, because the area of the square is just the side length squared. So yeah, either one of those, perimeter or side length, either one, but we don't have to have both. maybe I should just try to explain my thinking a little bit more here. We saw from the graph that we could start with perimeter and wind up getting area. But let's just say that we had a square, if I could only draw one. So imagine that this is a square. With a square, all the side lengths are the same. They're all S. So this side length is S. 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 The area is just S times S, S squared. And so we could determine the area if we knew the side length. But also, as we saw from the graphs, if we know the perimeter, which is just 4 times S, we could then find the side. Like if the perimeter was 4, we know each side has to be 1. So then once we know the side, then we could determine the area. Let's look at parts 2 and 3. I think these are kind of related. So part 2, using the graphs above, determine the area of the square when the perimeter of the square is 8 feet. So the perimeter of the square is 8 feet. So we can look right here at the perimeter of the square is 8 feet. That's our output. And at that point, the side of the square is 2. Think back to that square I just drew. If we know there's 8 feet all around, then each side has to have a length of 2. And then, now that we know the side length is 2, we can look at our function here and see that the area is 4, or just 2 times 2. So this is getting back to this idea we had in class. That 2 feet, that length of the side, is the connection between the perimeter and the area. Like when we're doing composition of functions, there's always some link between two functions. Part 3. If we know that the area is the side length squared, S squared, and the perimeter is 4 times S, 4 times the side length, define a formula that gives the area of the square in terms of its perimeter. Notice that S is the length between these two. And so we just have to sort of find out how to relate A and P, given that S is a link between them. And notice that P is 4S. We can solve that equation for S. Then we're going to substitute it into this equation for A. First, P equals 4S implies that P divided by 4 equals S. Just divide both sides by 4 there. Now that we have S by itself, we can substitute that in this formula here. And so A equals S squared, or A will equal P over 4 squared. So we see that here A is S squared, and then we just take this value for S, P over 4, and substitute it here. A equals P over 4 squared, and we could, if you wanted to rewrite that, you don't have to at this point, but that's the same as P squared over 4 squared, or P squared over 16. Just one more side note here. This isn't really part of the problem, but we could let P be the name of the function P. We could say P of S equals 4S. And we could let A be the name of the area function. So A of S is equal to S squared. And we could also define like a function S in terms of P, which was P over 4. And what I really want when we do this problem here is the composition of functions. It's A composed of okay, it took me a while to think about this. It's A of S of P, or A of S of P, which means first find the output of S of P when P is the input, and that's P of 4. And then we plug that into the area function, A equals S squared, so that's P of 4 squared. Next problem. A farmer has 250 feet of fencing to create a rectangular pen. Draw a picture of the situation and label the relevant quantities. Okay, give me a second to do that. So here's my rectangle, my width on either side, and my length horizontally. I let L be the length of the pen in feet, W be the width of the pen in feet, and we know the perimeter of the pen is a constant, 250 feet, because I only have 200 feet of fencing, so I got to make my pen with those 250 feet. That'll be the perimeter outside here. Given that the farmer has exactly 200 feet of fencing, if the width of the pen is 40 feet, what is the length of the pen L? Recall, the perimeter of a rectangle is 2 times the length plus 2 times the width. If we just add up the length plus this width plus this width, we'll get our perimeter. So let's think about this. The width of the pen is 40 feet. So if the width is 40, we can plug in what we know into this formula. Our P is 250 and our width is 40. So 250 equals 2 times, here's our script L, cursive L, that's the length, plus 2 times 40. And then we can solve this equation for L. Okay, let's give that a try. 250 equals 2L plus 40, and I know that, or 2L plus 2 times 40, and I know that 2 times 40 is 80. Now I could subtract 80 from both sides of this equation, and I'll get 170 equals 2 times L. Next, L is multiplied by 2. I can divide both sides by 2, and then L equals 170 over 2. And notice that it makes sense. If twice the length is 170, then the length has to be half of 170. And that comes out to, I'm thinking, 85. So that's length 85 feet. Part C, given that the farmer has exactly 250 feet of fencing, if the width of the pen is W feet, what is the length of the pen L? So let's just go back to our formula. We know 250, that's our perimeter, equals 2 times the length plus 2 times the width. In the last problem, we had a particular value for the width, and we plugged it in and solved our equation, subtracting 80 and dividing by 2. But we can pretty much mimic the same process with our variables. We can subtract this number, 2 times W, from both sides, just like we subtracted 80 in the last problem. 250 minus 2W, that equals 2L. Next, just like we did in the last problem, we can divide by 2. If twice the length is 250 minus 2W, then the length will be half of that. So here is our formula for the length of the pen. And let's take a second to practice simplifying. Notice that each of these numbers is divisible by 2. 250 is 2 times 150. Then we have our 2 times W, and we're dividing by 2. We can factor out that 2 on the top. 2 times 150 minus W, that's reverse distribution, over 2. 2 divided by 2 is 1, so we're left with our length being 150 minus W. 150 minus the width. And that kind of makes sense in terms of our picture here. Okay, next we want to define a function f that expresses the area of the rectangular pen measured in square feet as a function of the width of the rectangular pen measured in feet. Okay, so we want a function. Let's just think about what we want here for a second. We want a function that tells us the area, but we're going to name the function f. And this function f expresses the area in terms of the width. It's a function of the width. So it's f of w. That's what we really want. Now we know that the area is the length times the width. And we know that the length is 150 minus w. So the length times the width is equal to our area. And we want our area to be given by the function f. So f of w, that tells you the area when you have a width of w. Almost, except I made a small mistake with my division up here. 250 divided by 2 is 125. And so this is 125. It's okay to make mistakes, guys. Hopefully you caught that one. And I'm not just saying it's okay to make mistakes because I make them sometimes. It's because it's good for you to take a risk in class. Last problem, number 5. A bakery is known for their chocolate cakes. Let M represent the number of cakes made, and let S represent the number of cakes sold. Their weekly profit, P, is given by the equation P equals 22S minus 9M. Assume that the bakery has a weekly profit of $515 and made 65 cakes that week. How many cakes were sold that week? So let's just work with what we got. We have P equals 22S minus 9M. And P is our profit. And we know that the profit was $515. So we can just replace this P with 515. Substitution. Okay, let's see if we know S or M. S is the number of cakes sold and M is the number of cakes made. And we know that they made 65 cakes that week. So we don't know S. Now all we got to do is solve this equation. So negative 9 times 65, that's negative 585. So we have 515 equals 22S minus 585. And then I'm getting a little bit carried away here. I've added my 585 to each side to get 1,100 is 22S. Then our last step, since 22 times S is 1,100, then 1,100 divided by 22 will give us S. So we get 50. They sold 50 cakes. Part B. Suppose the weekly profit is 515 and M cakes were made at the bakery that week. Write a formula that determines how many were sold that week. So this time we know that, let's see, our profit again is 22S minus 9M, but we know our profit is 515 just like in the previous problem. But, we don't know how many cakes were made. That's okay. We can just solve for S just like we did in the previous problem. There we calculated 9 times 65, but here we don't know what 9 times M is, but it's some number that we can then add to both sides. So we have 515 plus 9M equals 22S. Then, just like we did up here, we divided by 22, and so S is equal to 515 plus 9M over 22. Part C. Chanel is the only baker in the shop, and she gets paid based off the number of cakes she makes and the number of cakes she sells. Assume that she earns $10 for every cake she earns, and $5 for every cake she sells. I'm thinking this must mean cakes she makes, I guess. $10 for every cake she makes, and $5 for every cake she sells. Write a formula that gives her commission C in terms of the number of cakes she makes M and the number of cakes she sells S. So her commission C. So C will be $10 for every cake she makes, 10 times M, plus $5 for every cake she sells, 5 times S. Part D. Write a function T that gives Chanel's commission C in terms of the number of cakes she makes in a week. So now we want a function T that gives her commission. So C is what we want, but we're going to use our function T, and that's a function of the number of cakes she makes, T of M. Well, we know that the commission is 10M plus 5S, and we know that S is 515 plus 9M over 22. So this function T is simply 10M plus 5, and we just want the function in terms of M, not S. So we just substitute what we have here for S, 515 plus 9M over 22. You could simplify that if you want to get some sort of linear function, but I think that's enough for now. Thanks for watching.